Hi guys, in this video we are gonna see how four-quadrant chopper circuit works. First of all, chopper circuit is a device which converts fixed DC into variable DC. This conversion is done using AC link chopper and DC link chopper. AC link chopper converts DC to AC and then step down it and then again convert it into DC. DC chopper straight away converts DC to variable DC. Based on the arrangement of switches, they are classified into first quadrant, second quadrant, two quadrant, four quadrant. They are also named as type A, B, C, D, E. Now we are gonna see type E chopper. This is the how to say four quadrant chopper circuit. It should be having four switches: CH1, CH2, CH3, CH4, and each switches will be operated for each quadrant operation. For example, CH1 will be operated for CH for first quadrant operation, CH2 for second quadrant, CH3 for third quadrant, CH4 for fourth quadrant. Here, for first two quadrants, the polarity of the E will be like this. The reason is the voltage supply will be made to flow in this direction. Hence, consider a motor where EMF will be produced opposing that supply. Hence, only we are hence that polarity. That's the reason behind the polarity. In third quadrant and fourth quadrant, supply will be made to flow in this direction. Hence, the polarity of the EMF is made like this in this. Now let us see the for each quadrant operation. In first quadrant operation, CH1 switch will only be operated, and CH4 switch will be always on or closed, and CH3 and CH2 switches will be open always in first quadrant operation. When CH1 gets on, the current will be flowing through CH1, LE, and CH4 through here. During that process, L will be get charged, and we can see that voltage is positive at this side and negative at this side, and current is flowing in clockwise direction. Hence, we can see that voltage is positive and current is also positive. That's why we are calling it as a first quadrant operation. Here is a voltage is positive, current is also positive, first quadrant operation. When CH1 gets off, the energy stored in inductor will be made to freewheel through CH4, D2, and E. This is the first quadrant operation. In second quadrant operation, all the switches will be made off. Only a CH2 switch will be operated. When CH2 is on, the EMF here, the EMF E will be producing current made to will make the current to flow in through CH2 L, CH2, CH4 to L. During this process, L will be get charged, and when CH2 is made off, the energy stored in the inductor, that is so potential at inductor VL, will be larger than Vs, and due to that, the diodes will get diode D1 and D4 will get forward bias, and the current will be made to flow from load to source through D1 and D4. This is the second quadrant operation. Consider this circuit for third and fourth quadrant operation. The reason is the current will be made to flow in this direction, and the polarity of the E will get changed. That's why this circuit. For third quadrant operation, CH3 will be operated, CH1 and CH2 will be get off, and CH2 is always on. When CH3 is on, current will be made to flow through CH3, EL, CH2, and negative. Here the voltage is positive at this side, negative at this side. Hence the output voltage will be negative, and the current is flowing in anti-clockwise direction. Hence its current is also negative. Hence it is third quadrant operation. Even when CH3 gets off, the energy stored in inductor will make the current to freewheel to CH2 and D4. Now for fourth quadrant operation, CH4 will be made on and all other switches will be off. During that process, the current will flow from E, CH4, D2, and L. During this process, L gets charged. When CH4 gets off, the potential at L will be higher than the source voltage, and that voltage will make the diodes D3 and D2 to forward bias, and the current will flow from load to source. This is the fourth quadrant operation. This is simple graph which explains all the four operation, and in each operation what are the switches are operated, and the path current flows. Everything is simplified in this graph. Now consider this chopper drive circuit, which is like an application of four quadrant chopper. In chopper four corner super circuit, there will be L and E. Consider this L and E as a motor. uh, Motor, the motor will be having resistance, inductor, and when the supply will be given, and armature and back EMF will be produced. That's the E. Now consider this circuit. When Consider the first current operation of a stopper circuit. Current will be flowing in this direction, right? When current flows in this direction, a back EMF will be produced opposite to it. That's a basic concept of DC motor. Due to this, the motor will be rotating in forward motion. This is called forward motoring. Okay. Uh, in second quadrant, during the second quadrant, supply will be cut, and the current will be flowing in this direction only. Okay, as in second quadrant, due to the inertia, the motor will be rotating, due to which EMF will be constantly produced. Okay, so this that is DC motor is converted into a DC generator. And now the current produced will be given to source or any other external load to D1 and D4. That's the operation in second quadrant, due to which the current will be extracted from the generator. Hence the constantly, and hence we can see that current is flowing in reverse direction. It is rotating in forward direction, but current is flowing in reverse direction. So an opposing torque will be produced in the direction of current only. So for the forward movement torque, an opposing torque is produced. Hence the braking is applied. That's why it's called forward regenerative braking. Now consider the third quadrant operation, where the current will be flowing in this direction. So due to that direction, the EMF is induced opposite to it. Hence the polarity will be get changed, plus minus. So current is flowing in this direction, and so the torque will be produced. Due to that torque, the motor will be rotating in this direction. Alright. So this is called a reverse motoring. Okay. Now consider the fourth quadrant operation, where supply will be get cut. So due to the reverse motion of the motor, and it becomes the DC generator due to its inertia, and EMF and current will be induced opposite to it, and that current will be made flow to D3 and D2 to an external source, I mean given source or external load that will be utilized and capacitor like that. So due to the flow of current in this direction, a torque will be produced in this direction, but our motion is in this direction. So for that movement, reverse torque is produced. This is called reverse regenerative braking. This regenerative braking concept has been used in trains. This is a simple problem to find out a critical inductance. Critical inductance is nothing but when the output current falls to 0 at t is equal to t in the inductance, then it is called critical inductance. This is the formula, and thank you.